Hi guys, so for today, let's concentrate on integration by trigonometric substitution. And para mas madali nyo masundan yung flow ng ating discussion, I will divide this into three separate parts. So of course, this is the first part ngayon. So let's recall the general idea of trigonometric substitution. So suppose let's let a be a positive real number and let's let u be a function of x. So yung u natin dito, this is our variable, no? Then what's the idea of trigonometric substitution? Essentially, you have here a certain integrand, an integrand of a specific form, and usually that form is much more difficult to integrate, no? Or oftentimes we cannot integrate that in its base form. So yung ginagawa natin is we introduce a substitution involving trigonometric functions para itong old integrand na to, after introducing that substitution, that will now become an integrand which is easier to solve. And in this case, since we're introducing a trigonometric substitution here, this new integrand, this will of course involve trigonometric functions, no? So we have here now a trigonometric integral, which by the previous topic on trigonometric integrals, you should be able to solve. Okay, let's just go over the forms one by one. So let's start with the square root of a squared minus u squared. So constant squared minus function squared. Ano yung magiging substitution natin dito? Essentially, you now let u be equal to a times the sine of theta. Okay? Where your theta here belongs to either quadrant 1 or quadrant 4. So it's the closed interval from negative pi over 2 to pi over 2. Okay? Tapos, after introducing that substitution, if you now substitute u equals a sine theta in this expression, what do you get now? So after applying identities, this old integrand will now simplify to a times cosine theta. So from sine theta, naging cosine theta tayo ngayon, no? Okay, next, we can also have the square root of function squared plus constant squared. So u squared plus a squared. And then ano yung magiging substitution natin in this case? We now let u be equal to a times the tangent of theta this time, no? Where your theta belongs to almost the same interval, except we exclude both endpoints. So your theta now belongs to the open interval from negative pi over 2 to pi over 2. So it's again quadrants 1 and 4, pero we exclude negative pi over 2, which is the negative y-axis. Tapos, we also exclude the positive y-axis, which is pi over 2. Right? Tapos, after applying this substitution, if you replace u with a times tangent theta in this expression, this should simplify to a times the secant of theta. So if you notice, magka-partner si sine and si cosine, si tangent and si secant, no? So ganun lagi yung case kapag nag-apply tayo ng isang trigonometric substitution. Okay, finally, we can have the square root of variable squared minus constant squared. So square root of u squared minus a squared. In this case, what is our substitution? We let u now be equal to a times the secant of theta this time. Okay? Where your theta belongs to a different set of intervals. In this case, your theta must belong to 0 to pi over 2, yung quadrant 1, or it should belong to quadrant 3, which is from pi to 3 pi over 2. And in this case, we exclude pi over 2 and 3 pi over 2, no? Kasi undefined si secant at those points. In fact, ganun din kay tangent theta. It's not defined at negative pi over 2 and at pi over 2. Okay? So if you now replace u with a secant theta in this expression, that will simplify using identities again into a times the tangent of theta. So again, kapartner ni secant si tangent, no? So para mas madali nating ma-ingest yung trigonometric substitution, let's start with this example here. Let's determine the integral of dt divided by 4 plus t squared all raised to the power 3 halves. So first, let's express the integrand in radical form. So si 4 plus t squared all raised to the power 3 halves. Remember, anything raised to the power 1 half, that's the square root of that something as well. Okay? So if you replace this in radical form, this should now be dt divided by the square root of 4 plus 3 squared, or rather 4 plus t squared, all raised to the power 3. Okay? So remember, 3 ang numerator natin dito. Okay? Tapos what do you notice here? This integrand here is of the form, you have here constant squared, so 4, and then plus function squared, which is t squared. Okay? So in this case, what is your u? Yung u natin dito is t. Okay? Kasi t squared to. Tapos what's your a? Yung constant natin is just the square root of 4 here, which is 2. Okay? So it's very important to be able to identify what your u and what your a is, no? Kasi this will be the very basis of what substitution we will use. And of course, the integrand as well. Right? So your u is equal to t. Your a is equal to 2. So yung integrand natin is of the form square root of u squared plus a squared, no? So variable squared plus constant squared. What's our substitution kapag variable squared plus constant squared? It's now u, which is t. It's equal to a times the tangent of theta, no? But your a here is 2. So you have here 2 times the tangent of theta. Okay? Pero again, where does your theta belong to? Your theta belongs to the open interval from negative pi over 2 to pi over 2, no? Remember, it's open kasi non-defined si tangent theta at negative pi over 2 and at pi over 2. Okay, what's our goal now? Our goal now is to express this integrand in terms of theta ngayon, no? So yung dt, we need to express that in terms of theta. Yung 4 plus t squared, we need to express that as well in terms of theta. Okay? So let's do that. Yung dt natin, let's start with dt. Ano yung gagawin natin to get dt? We need to differentiate this expression here, no? So you have here dt equals, ano yung derivative ngayon ng 2 tangent theta? So yung 2, upon differentiation, lalabas yan. And then times, what's the derivative of tangent theta? That should give you secant squared theta, no? You have 2 times secant squared theta. And of course, don't forget the differential d theta, no? So your dt, that's now 2 secant squared theta d theta. So, itong dt natin, okay na siya. Tapos, yung denominator naman, si square root of 4 plus t squared. Let's do that as well. So, yung t natin, remember, it's 2 tangent theta, no? So, if you replace 2 tangent theta to t in this expression, you should get what? If you square t here, you should get 4. 2 squared is 4. And then times tangent squared theta. So, this t squared is 4 tangent squared theta. Tapos, what do we do next? We factor out 4, no? So, kapag finactor out natin yung 4 dito sa dalawang terms na to, you get 4 on the left times 1 plus tangent squared theta ang matitira. Okay? And then let's separate these two in their square roots. So, you have here the square root of 4 on the left times the square root of 1 plus tangent squared theta. Pero remember, if you use identities, what's 1 plus tangent squared theta? That should be equal to secant squared theta. Tama ba? You have here the square root of 4. And then times the square root of this one is now secant squared theta. Okay? Pero what's the square root of 4? It's 2. Tama ba? Yung square root ng secant squared theta, technically, it's the absolute value of secant theta. So, bakit magiging secant theta na lang yan? It's because theta belongs to this interval, no? Remember yung theta natin, it's from quadrant 1 or from quadrant 4. Tama ba? If you take secants of angles in quadrant 1, they will be positive. Ganun din for quadrant 4 angles, no? Their secants will always be positive. Okay? So, kapag nag-absolute value kayo ng secant theta, which is positive, its absolute value will just be itself. Okay? Kaya legal, no, na mag-secant theta lamang dito. So, this will simplify now to 2 times the secant of theta. Okay? So, it's also important to determine, no, the restrictions of the angle theta kasi that will allow us to remove absolute value bars. Okay? Okay, so you now have dt in terms of theta. You have 4 plus t squared in terms of theta as well. So we can integrate now. So the old integral, if we now express that entirely in terms of theta, what do you get? So your dt, remember si dt, it's 2 secant squared theta d theta, no? So replacing dt with this one here, ito yung magiging bago nating numerator. Tapos yung baba naman, si square root of 4 plus t squared, di ba, it's 2 secant theta. However, you're cubing the denominator. So let's cube this as well. We take the cube of 2 secant theta, 2 cubed is 8, times secant cubed of theta. So this is now your new denominator. And then let's simplify a bit. Yung 2 over 8, of course, that's 1/4. Tama ba? And then what's secant squared theta divided by secant cubed theta? So by loss of exponents, what should you get? You get secant raised to the power 2 minus 3 of theta. Tama ba? But 2 minus 3, diba, that's negative 1. So you get secant theta all raised to the power negative 1. Tama ba? So it's just 2. So it's just 1 all over secant theta. You have 2 over 8, which is 1/4. And then times secant theta all raised to the power negative 1. That's 1 over secant theta. Okay? And then si 1/4 labas natin. And then what's 1 over secant theta? Remember, secant is the reciprocal of cosine, no? So 1 over secant theta, that should just give you cosine theta. Okay? You have 1/4 times the antiderivative of cosine theta d theta. Okay? So what's the antiderivative of cosine theta? Ano yung function na kapag dinifferentiate ninyo, magiging cosine theta yung result? So remember, it's equal to sine theta. Okay? Kasi when you differentiate sine theta, that should give you a cosine of theta. Okay? So remember, positive to, no? Kasi we're integrating. Kasi, di ba, kapag nag-differentiate kayo ng cosine theta, that should give you a negative sine theta. Pero take note, in that case, you're differentiating. This is an integration process. Okay? So always remember which process you're doing, ha? Always remember that you're integrating. Always remember that you're differentiating when the time comes. Okay? We have here 1/4 times sine theta, and then plus, of course, the arbitrary constant c. As usual, you never forget about this arbitrary constant, no? Okay, we're not yet done kasi the old integral is in terms of t. The antiderivative that we got is in terms of theta. So yung goal natin ngayon is now to express sine theta in terms of t only. Okay? And how do we do that? Essentially, we use this substitution that we made here and we make use of right triangles. Okay? So, di ba, we let t be equal to 2 tangent theta. If you divide both sides by 2, you should get, of course, tangent theta to be equal to t over 2. Tama ba? Okay, remember, what's the right triangle definition of tangent theta? Di ba, tangent theta, it's equal to the opposite side all over the adjacent side. Tama ba? So, if this is now your right triangle, and say this is your theta here, ano yung side opposite kay theta? It is t, no? Kasi opposite over the adjacent side, that's now 2. Okay? So this is the side opposite to theta here. This is the side adjacent to theta. Okay? And then how do we get the remaining side? Essentially, we're just looking for the hypotenuse of this right triangle, no? And how do we determine the hypotenuse of this right triangle? We use the Pythagorean theorem, no? So by the Pythagorean theorem, what's the hypotenuse equal to? It's just the square root of the sum of the squares of the legs. Tama ba? You have the square root of t squared plus 2 squared. So you have now the square root of t squared plus 4, or 4 plus t squared. Okay? Okay, you now have here all three sides. And remember, we are looking for sine theta. Tama ba? In terms of t. So para mahanap natin si sine theta in terms of t, we again make use of the right triangle definition of sine theta, no? So what's sine theta? It is opposite divided by a hypotenuse. Tama ba? So this is again your theta. What is the side opposite to theta? It's t. Tama ba? And then divided by the hypotenuse, it is the square root of 4 plus t squared. Okay? And then we're done, no? So we now have sine theta in terms of t. So yung integral natin, which is what we computed to be 1/4 sine theta plus c, we now replace sine theta with this one, you now get t all over 4 times the square root of 4 plus t squared and then plus c. So this is now the antiderivative of that one. Okay? And you can check now, if you differentiate rather this function here, you should end up precisely with this one. Okay? Okay, next example number 2. Let's find the integral of dx divided by 1 plus the square root of 1 plus x squared. Okay, so in this case, you have now the square root of constant squared minus function squared, no? So in this case, what is your u? Your u is just x, of course. Tapos, what's your a, the constant? It's just the square root of 1, which is, of course, 1. Okay? Your u is x, your a is 1. Using these two, let's now determine the trigonometric substitution. So, yung substitution natin kapag constant squared minus variable squared, it is u equals a times sine theta, no? Pero what's your a? It's 1 times sine theta. Remember, your theta again belongs to quadrant 1 and 4. This time, you include the endpoints. Okay? So, what's our goal ngayon? Our goal is to express dx in terms of theta and itong square root of 1 plus x squared in terms of theta as well. So, what's your dx in terms of theta? So, when we differentiate itong x equals sine theta, to get dx to be equal to what? What's the derivative of sine theta this time? You get now cosine theta. Okay? So, your dx is cosine theta and then times, again, don't forget the differential, no? Baka mabawasan kayo ng partial points kapag hindi nyo in-include yung differential na yan. Okay? Your dx is cosine theta d theta. Okay na to. Itong numerator natin. Let's now concentrate on this one. So, the square root of 1 minus x squared, let's replace x with sine theta here. So, if your x is sine theta, you get now the square root of 1 minus sine squared theta. Tama ba? Pero using Pythagorean identities, yung 1 minus sine squared theta, what do you get there? So, yung 1 minus sine squared theta, that's just cosine squared theta. Okay? And again, the square root of cosine squared theta, technically, that's absolute value of cosine theta. Pero again, your theta belongs to quadrants 1 and 4. If you take cosines of angles from those quadrants, they will end up to be positive. Kaya yung square root ng cosine squared theta, that should just be cosine theta. Okay? Okay, so you now have here your dx in terms of theta. You now have here square root of 1 minus x squared in terms of theta. We're now ready to integrate. So let's just take note of the substitutions. Ito yung dx natin. Yung square root ng 1 minus x squared natin is this one. Okay? So this integral, in terms of theta, what do you get now? Yung dx, let's now replace that with cosine theta d theta. So you have that one in your numerator. And then itong denominator, si square root of 1 plus x squared, that's cosine theta. Tama ba? So ito, magiging 1, and then plus this one will turn into this one. So you now have 1 plus cosine theta. And then how do we integrate this ngayon? So halimbawa, if you let u be equal to 1 plus cosine theta, then your du is yung derivative ng 1 at 0 plus derivative ng cosine theta is negative sine theta, no? So your du is negative sine theta d theta. However, that's a problem, no? Kasi walang lumilitaw na negative sine theta d theta dun sa integrand natin. So in this case, what do we do to be able to integrate this? Ang gawin natin is, yung 1 plus cosine theta, let's take the conjugate of that, and then multiply and divide. In other words, let's multiply and divide by 1 minus cosine theta. Okay, and then let's perform the multiplication here. We have cosine theta times 1 minus cosine theta on the numerator. Let's leave that as is muna. Tapos you have here on the denominator a difference of 2 squares ngayon, no? You now have here 1 squared minus cosine squared theta, or 1 minus cosine squared theta. Then of course times d theta here. Okay, and then remember, si 1 minus cosine squared theta using Pythagorean identities, that's again equal to sine squared theta. Tama ba? So your denominator, that now becomes sine squared theta. And then what do we do next? Yung sine squared theta, let's split that into 2 factors, no? Let's write this as sine theta times sine theta. And then one of the sine thetas, let's group that with cosine theta here. Yung isa pang sine theta, let's group that with 1 minus cosine theta. Okay? So what will this be equal to now? This will now be equal to cosine theta over sine theta. This is the first sine theta here. And then times 1 minus cosine theta all over sine theta. Okay? These two are just the same thing. Okay? And then let's now again use identities to simplify this. So si cosine theta over sine theta, that is just cotangent theta. Tama ba? Tapos, itong kanan naman, si 1 minus cosine theta all over sine theta, let's write this as a difference of 2 fractions. So this is now equal to 1 over sine theta minus cosine theta over sine theta. So you get this. Okay? And then si 1 over sine theta, what's that equal to? Remember, si sine ay reciprocal ni cosecant. So si 1 over sine theta, that's just cosecant theta. Okay? You have cotangent theta, and then times this one will turn into cosecant theta. And on the other hand, si cosine theta over sine theta, like I mentioned, this is equal to cotangent theta. Okay? So the next thing to do is to distribute and then to integrate term by term. Okay? So if you distribute, you get to cotangent theta times cosecant theta, and then minus cotangent, that will give you cotangent squared theta d theta. And then let's split the integral and integrate term by term. Okay? Let's start with this. This is relatively simple. Ano yung antiderivative ng cotangent theta cosecant theta? So let's think of a function that will give you a derivative of cotangent theta cosecant. And that function is more or less cosecant theta, no? Kasi when you differentiate cosecant theta, you should get cotangent theta cosecant theta. Okay? So with a negative sign, of course, don't forget it. So derivative ng cosecant theta, it's negative cotangent theta, cosecant theta. Tapos kapag naman biniligtad niyo yung process, if you now integrate cotangent theta cosecant theta, you should get now negative cosecant theta. Okay? Again, remember kasi derivative ni cosecant, it's negative cotangent cosecant. Negative of negative, that will give you positive. So you return to this. Okay? And on the other hand, what is the antiderivative of cotangent squared theta? So wala tayong known na formula, no, for cotangent squared theta itself. However, we can again use identities to express this in terms of an antiderivative which we know how to compute. Okay? So si cotangent squared theta, using identities, what's that equal to? It's equal to cosecant squared theta minus 1. Okay? Tapos, ano yung cosecant squared theta? We know how to anti-differentiate that, no? Ano yung function na magbibigay ng cosecant squared theta as a derivative? So if you recall, if you differentiate cotangent theta, that should give you negative cotangent theta. So kapag biniligtad yung process, the antiderivative of cosecant squared, it's just negative cotangent. Okay? So it's important, no, to be able to express this from an integral you don't know into an integral you know. Okay, and then like I mentioned, let's differentiate now this term by term. So like I mentioned, si cosecant squared theta, yung antiderivative niya, it's negative cotangent theta, no? So negative of negative, that will now become positive cotangent theta. Okay? And then minus, what's the antiderivative of 1 in terms of theta? Of course, that's just theta, no? This is minus theta, pero negative of negative again, that will again give you positive theta. Okay? So this is now the antiderivative in terms of theta. Okay? Again, our goal is to re-express this in terms of x. So again, what's our goal here? Our goal here is to find cosecant theta, cotangent theta, and theta in terms of t. Okay? Yung theta, that's more or less simple. Yung x natin, it's sine theta, no? And then we can take sine inverse of both sides, yung theta, that will now be equal to the inverse sine of x. Okay? So this is your theta in terms of x. Okay na yung theta. Okay? And then for cotangent theta and cosecant theta, again, we make use of right triangles, no? So this is your theta. Tama ba? Now, what are we given? We're given x to be equal to sine theta. Tama ba? Pero sine theta, yung x natin, that's equal to x over 1. Tama ba? And by definition, si sine theta, that is opposite over hypotenuse. Tama ba? So in this case, your opposite side is x divided by the hypotenuse is 1. Okay? So this is your theta. What's the side opposite to theta? It is x. Okay? And then hypotenuse, yung 1 natin. Okay? So what do we do now to get the value of the other leg? Essentially, now take the square root of the hypotenuse squared minus the remaining leg squared. You have the square root of 1 squared, that's 1, and then minus x squared. Okay? So always remember that when you're looking for the values of the leg, you get the square root of hypotenuse squared minus the remaining leg squared. Kung hypotenuse yung hinahanap nyo, it's square root of the sum of the legs squared. That's always true. Okay? So we now have here your three dimension, or rather your three angle lengths, or your three side lengths, sorry. So we can now determine cotangent theta and cosecant theta using this. So your cotangent theta, remember that's the reciprocal of tangent theta. Tama ba? By definition, si tangent theta, that is equal to what? That's equal to opposite over adjacent. Tama ba? But you're taking the reciprocal. So yung 1 over tangent theta, that's now equal to adjacent divided by the opposite. Okay? So this is your theta. What's the side adjacent to theta? It is the square root of 1 minus x squared. Tama ba? And then divided by the opposite side, that's just x. Okay? So this is now your cotangent theta in terms of x. Tapos yung cosecant theta naman natin, what do we do here? Remember, si cosecant theta, di ba that's the reciprocal of sine? It's 1 over sine theta. However, yung sine theta natin dito, it's equal to x. Tama ba? So si 1 over sine theta, that's now equal to 1 over x. Okay? So this is now cosecant theta in terms of x. In fact, si cotangent theta, you can also express that in terms of x without using right triangles, no? So remember, si cotangent theta, that's equal to cosine theta over sine theta. Kung sine theta, okay yan, no? It's given by this one. Tapos yung cosine theta naman, it's equal to this one. So in fact, you can solve this without making use of right triangles. And in fact, we will have examples wherein we don't use right triangles. Okay, so you're done, no? This is your cotangent theta. This is your cosecant theta. You can now re-express the antiderivative that we got in terms of x. So itong integral natin, which we computed to be equal to this one, let's now replace values. So si cosecant theta, it's 1 over x. So this will become negative 1 over x. Yung cotangent theta, that is equal to this. Tama ba? So we replace this one with this. Tama ba? And then yung theta natin ngayon, it's now equal to sine inverse of x. So replace theta with this. And then plus c. And you're done, no? This is now the antiderivative that we have. Okay, so that ends part 1 muna. So to conclude part 1, I want you to solve all of these exercises for practice para makapag-practice kayo for you to be ready. Okay? So again, that ends part 1. For part 2, yung focus natin is on integrals that don't have this expression readily on them, no? So what if meron kayong integral pero hindi siya agad of this form? So that's for part 2. Okay, thanks for watching.